you have your microphone?
It's on.
Okay, great.
Hello. Hello. Thank you for being here. Thank you for the invitation. I want to talk about differential privacy, but not just the technical details of it, how to implement the differential privacy thing, in particular the algorithm, but also why we need it in general. Why we need that tools to keep the privacy as individuals, but also as society, because it's not only that we need privacy to prevent from an attack, from someone who wants to use our personal data to attack us as individuals. This is like the vaccines. I mean, you can protect your data and you can protect your privacy, but if no one else around you is also protecting the data, it's absolutely useless. So we really need societies to be protected from attacks to the privacy. And we have some cases in the last years that was really obvious what it means. I mean, I think you are aware of the case of Cambridge Analytica and Facebook and how they use the data for the political campaigns in the States. No? And at the end, I can make a brief summary. There was a leak of data of millions of users from Facebook, and all this data was used massively in order to make profiles, ideological profiles. It's not just that you wake up at this time and you have these friends, but which is your political color in that sense. No? So it's really personal, that thing. And it's not just that it's an attack, it's an attack to you. It's a massive attack. It's an attack to society, no? And the grounds of it, the democracy itself. So that's important. It's really important. And we should be aware that this is not just a case, random case that happened in the States. Because just last week in Spain, I'm from Spain, so this is really personal for me as well. Someone say that someone has a really great idea. They say that indeed that was a mistake, the thing with Facebook and the data. So the great idea, in order to prevent that to happen, is like, let's make it legal. So really, they vote and they approve this law that allows for political parties to use any data they find in the internet, any data they find in the social media, to make profiles, ideological profiles, and that they can approach you. If you put your email somewhere, they can send you an email. They can target you. And if you put your phone somewhere, they can call you to make propaganda for you. This is crazy. I mean, obviously it's against the privacy law in Europe, and probably will not go further than this. No? But I mean, we should be listening, because as far we don't keep the attention, someone will try to really go after that. No? And this is, I mean, for me it was important, not only because I'm Spanish, but because I participate myself in the last presidential elections. So we offer our tool for electoral campaigns there. We offer our tool to the four main parties. It was a really tough election. Only one of them at the end decided to use our tool, that I will explain what we did later. No? At the end was the People's Party, the one who won the elections, eventually, who used our tool. I will not say that thanks to our tool, but I like to think that we had something to do with that. But in principle, it's important also why these people want your data. Why these people want as much data they can about you. It's about micro-targeting. Make profiles about you and then micro-targeting. Really not go to the mass, going to you and talking to you and trying to sell you an idea, a product or something. And in the last years, it was obsessive for many companies. Take as much data as possible as they can. Put all this data together and they will figure out what they do with this data. No? In the beginning, they don't even know what to do, but at the end, they will figure out. And they figure out. But, I mean, I want to show there are two approaches. there are two approaches how to handle this data. We can do this profiling and micro-targeting, take everyone and put all the data about this person there in a profile, or we can just check the crowd trends, that you don't see anyone as an individual, you see a crowd, and what matters is the trend of this crowd. You are not interested in which person and who did what. You are interested in how many is doing that. And I think that we can make marketing or electoral campaigns that target crowds instead of individuals, because also you want to sell 1 million, not just 1 or 2 or 3. So this is a completely different mindset, how to approach the problem and how to solve it. But it's also even deeper. I like to read, I'm a physicist, so I love the science fiction and mostly Asimov as an author, and he has this sentence, that is, the reaction of one man could be forecast by no mathematics. The reaction of a billion is something else again. It means that we as individuals, we are unpredictable. So we might have patterns that are very predictable. We wake up at 7 in the morning, we go to our office, we spend the day there, we go to have lunch, we go back home, we visit the family, but yeah, those are the most general trends, that is obvious. But there are many other variables that this is just the lottery numbers. I mean, there is a lot of us that we have control, and a lot of us that we have no control at all. And that's good. I mean, it's how things is, how life it is. So you can predict general trends and the aggregation of these trends that are predictable, but we should not even try to predict what is unpredictable. We should not try to predict the lottery numbers. There is no reason to do that. And I mean, you can see people working in big data that it's like, in order to get this 1% extra in predictability, they think that they need 90% more data in order to increase that. And probably it's not. I mean, there is a limit. There is a limit in this predictability, right? So in order to get this 1%, it's a very high price, probably, that we need to pay in order to get it. And that should not be that way. So what we were doing, we were checking the crowd. So we were checking mostly where most of the people is joining or the places they are visiting. And actually, for these electoral campaigns, instead of going to particular people here and there, we were targeting locations in general because of the probability of finding people of certain demographic profile in that area. So we wanted to prove two things here. The first, you don't need to cross that red line that is the privacy, and you don't need to really do the micro-targeting to the people. But instead, you can find a strategy that tells you places where the candidate can go and visit the people that is there, and also show an image of closeness to your voters. So we were telling the candidates and volunteers to be in certain places in the street in order to meet with the potential voters. So it's a completely different approach. It's not them going to the people, it's the people coming to them. And that was making really a difference. But we need numbers, actually, to prove that as well. No? And we did. I mean, we could prove that there was a correlation between the number of actions that were done in the streets in order to show this closeness with the people with the extra votes they got in this location. So it's, as you see, it's a completely opposite way to use the data and to execute the campaign. But of course, this is not only about electoral campaigns. So there are many other applications that we think that is good for society in general. One of them is transportation. I mean, we can use this data to create these trajectories here that allows us to understand how the roads and the highways are used by most of the people. That's good for tourists as well, and mostly for smart cities to understand a bit better what's the city. But again, talking about crowds, about how many people is going to a particular place, not who is going to that particular place. So this is a completely different question and a completely different mindset. But indeed, in order to get that, in order to get the data for the crowd, you first need to analyze the data for the individuals. So that's the part that should be done in a very specific way, in a very smart way, I would say. How you take the data, like it's really individual data, and you transform it into something that makes sense for the crowd. And that's the challenge of the technology. And here is where we can introduce differential privacy, the concept of differential privacy. I will not go to the algorithm itself. I will go about why it's important and why we should use it. And imagine that case. Yes, there's a Twitter survey, no? A particular question, yes or no, and you have everything here is anonymous and aggregated data. We know that 50 people vote. We know that 68 of them vote no, and 32% of them vote yes. So in principle, you know nothing about the people who vote here. And you know nothing about who should vote whatever. But imagine the situation. You just see someone voting at that particular moment. You didn't see what they vote, but you see that person voting at that particular second. And you check the numbers again. And the numbers have changed. Now there is 51 voters, right? And the proportion have changed. And if we compare these numbers with the previous ones, we have 33% for yes, but before was 32%. It's obvious then. I mean, it's obvious for whom this person voted, no? And that's the full point of it. So you can have a database that is secure, that you know that everything is aggregated data. You don't let others to know more than that. But if they cross information, they might figure out really personal data, and they can. Oh my God! They can really go into the detail of the privacy thing. So, and that's why it's called differential privacy. A differential change in this aggregated data can tell you something really private about the users you have in your database. So, how to solve that? The solution is noise. Noise in general. And what it means, actually. So imagine this situation. So every single entry here are these movie posters, right? They are located, they have letters, and they have located in several places, and you can recognize the movie here. We do noise, and then we don't recognize anything here. But you might say, why this is useful at all? I mean, yeah, there is no information left in there, no? So why is gonna be this useful? Actually, because I'm not interested in this pattern, I'm interested in this other pattern. So I'm not interested in the single posters, the movie posters that are there. I'm interested in Charles Chaplin here. I want to see the overall, I want to see the big picture, the contribution, how all these elements contribute to generate a big picture here. And if you see the noise, it doesn't change the picture. Maybe you even see it better. So I'm interested in Charles Chaplin. I'm not interested in the individual contribution of the posters, right? So this noise is enough to break the information about the individuals, but it's small enough to keep the relevant information about Charles Chaplin here. So that's the main concept of differential privacy. There is even a parameter called epsilon that tells you how big is that noise, how much you destroy the private information, and which is the size of the noise in your average that you have, because that's the main concept. You want to break what is the individual entries, that people becomes not recognizable at all. But you want to keep the average, you want to keep the aggregation, not the aggregated information that is there. So I will go a bit fast. How we use it for mobility data, in particular data that comes from mobile operators. So you know, mobile operators, everyone has a cell phone. This is massive data, it's millions of users. And every time you make a phone call, it's registered for billing purposes. Is when you make a phone call, which antenna you were connecting, and who you are. So as you can imagine, if we put dots together, we can tell how the people is moving. it's not very precise because we know the tower. We don't know the precise point in the street where you are. You are not using the phone all the time, so there are holes in the middle. No? So you have some dots here, some other dots later. So the data is noisy already in the very beginning. The raw data is already noisy. So the idea is how can we use this data that is useful? It's useful data, not because I'm interested in where this particular person lives or what this particular person is doing, just because the overall is giving me like the Charles Chaplin picture. This data is telling me how the people are using the roads, how they are using the streets, and that's useful for city planning and to improve actually our experience in the cities. So we have this pattern technology that basically works in that way. We have the raw data. The raw data is originally messy already. You have a lot of fluctuations because we have that part that I was telling that is not predictable at all. So if you've seen the first image, those are two areas, and those lines represent the people moving from one tower to another. And because there are these holes and it's noisy, yeah, there is kind of a pattern behind, but because of the randomness and the fluctuations, it's a bit blurred. So we make a first process that is kind of taking out some noise and adding some extra noise to that. And actually it's because we want to see the pattern, the general pattern, not the individual paths. In that sense, we are trying to make clear the image of Charles Chaplin there. This is my Charles Chaplin, where the people is going. But still there is an extra process that is, those are towers, those are the antennas, no? But we want to learn about the streets, how the people is moving in the street. So we run a simulation later that is also based in random numbers. It's a Monte Carlo process about people using the streets. And we just kept those that fit with the pattern, mobility pattern that we see. That we assign and score to every of these paths in order to generate the big picture. So as you see at the end, there are several layers between the final product, the final output, with the raw data. That is the personal thing. So at the end, you get something that is absolutely useless to identify a person, but super useful to understand what's going on in a particular region in terms of mobility. And that's the goal. I mean, if someone is using a road, I want to learn how many people is using that road, not if my uncle is using that road in particular or someone that I want to localize. I don't want to localize people here. I just want to see the general trend of people moving. And that's the idea, because at the end, this data is useful, and we should worry about privacy, but we should not stop sharing data somehow. I mean, what I mean is that we should not stop using phones at all, or we should not stop using internet. We should not stop using technology because someone is behind our data. It's fine if we use it, fine. We just need to take care of who is using this data and for what and how, no? And the purpose of that. I can also say we should trust some of the people, not everyone, how this data is used. But we should be aware. I mean, we cannot get asleep. We should track them as well they track us, right? I mean, we should track what they are doing with the data and make sure that this data is used in a fair way. And I will try to finish that, to finish fast, just with an example of how this data can be useful. This is, Woden's is a very beautiful town in Tyrol, in Austria, and the Swarovski factory is there. And they have a wonderful museum there. And we use that data about mobility in order to understand what was going on, because they have a huge traffic problem. It's a very small town, only 8,000 people, but the traffic was super nasty. And they thought that, they considered that the traffic was generated by the commuters going to the factory or the tourists going to the museum. However, we used this data to figure out what this traffic was coming from, and what we found is that was not the commuters, was not the tourists. It was the people from nearby towns that they were using Wotens just to cross by. just to go from this town to another. So it's basically people not stopping on the town. And well, how to solve that? I mean, actually it's easy. You can think, make a new road outside the town, but that's a lot of money, no? That's not really realistic. So happened that there is the highway. And the people was not taking the highway because, going to the entrance of the highway, then to the exit is shorter path, more efficient, just crossing the town. So yeah, reduce the velocity of the town. If you just reduce the velocity in the middle of the town, but you put a traffic light, it would be more efficient to go to the front, to go in the highway instead of crossing the town. And what I want to say with that is the power of data and data-driven decisions, and why it's useful to use this data and why we should continue using this data. I mean, we can solve some problems here, non-obvious problems, and we can make data-driven decisions based on that, but always respecting the privacy of the individual. Because I don't need to know who is the particular person taking this road. That makes no sense. I just want to know from where these people was coming, how many of those were coming, and why they were using the road. And those are the questions we need to respond on that. And okay, that will be it. Thank you very much. Yeah.
All right, thank you for a very interesting talk. Do we have any questions? All right, let's see. Oh, I'll get to it.
This is super interesting, and my question is actually, this noise concept, is it based as in human situations, like, for example, if you are in a silent room, and there is few people, if you're telling someone a secret, maybe you can hear, but if the room is completely full of people, you can share secrets if you want. Probably nobody will notice. Is it kind of the same concept?
Probably not, but in the sense, actually, the concept of noise came, there is a full theory about that, this mostly information theory, and the noise in the signal, and how you can reconstruct a signal that is under noise. So I can imagine the thing of telling someone a secret behind the noise, and you can keep secrets in the signal of the noise. I mean, you can do the reverse way. You just send noise, and actually the message is incorporated in that way. And that's a technique, actually. Here, the concept of noise is just to really introduce something that is fully random, that makes no sense, is not contributing in information, but doesn't change the average value. So it's a noise with mean value 0, in the sense that it respects the mean values, the overall aggregated values of your data set, but in every individual you are moving it a bit. So for instance, age. So you have a database with ages, gender, more information. You can add noise to the age, that the mean value of the age is the same. Even the histogram remains the same, but you have introduced to each individual plus minus some ages. And this plus minus is done in such a way that compensates at the end of the day. That's the concept of noise here. Introducing something that actually will disturb individual measures, but you try to keep it in the overall same results, same predictions in the macro, not the same in the micro.
Thank you.
Okay, I have another question, and in your view, how is personal data corrupted by noise treated by GDPR? Is it still personal data?
Yeah, no, that's a bit the point. I mean, if let's go to the image of the posters. In which moment it is not anymore the original poster, right? I mean, here you cannot read any letter, any words, or not even recognize any text. So the contribution of the noise is so big that the personal data just almost evaporates, or at least is impossible to recover that data. So in the very moment, I think that you cannot recover that personal data, it is not personal anymore, because the contribution of the noise is bigger than the contribution of the original data, I would say. It's also, I mean, this differential privacy has not only the part of the noise, but also that you can switch some results, in the sense that some results are fake, and some of them are real. So to the point that you cannot recognize, or you cannot know which data is real and which data is fabricated. That's also part of it. No? So if in the very moment that the fabricated part is bigger than the personal one, yeah, I think that it's out. I mean, as far you cannot recognize a person univocally. But that's my opinion. I know nothing about law.
Hi, thank you for a super interesting presentation. I have a question about how do you see, I missed you at the beginning of your talk, so maybe you mentioned this, but how widespread is the use of differential privacy in the
community?
Data in the community, and what are the trends? Maybe they're not used now, but it's in the verge of being used more?
Yeah, I mean, big players are already using that, no? As Apple and Google, I think, and some of them. So it's going to be a matter of time that.
Yeah, but
yeah.
Apple's implementation is supposed to be.
Yeah, I heard that. And yeah, I mean the idea, but it also only makes sense when you have a huge database.
Yeah.
That's also the thing, because if your database is small, I mean, it's hard to introduce the noise big enough that doesn't modify the average. So I mean, it's a tricky part. But for big data, I mean, for when your database is big enough, for me it should be kind of something standard. It should be something standard. I mean, even if for internal use, you even want to keep it like you can identify people because you have permissions for that. But in order to prevent attacks, that someone takes your database and wants to use it for other purposes, that you keep the noise. You know, so it's really impossible to really do something wrong with that. No? So yeah, talk about that. The best way to make something more common is talking about it.
Great.
Do you guys do a bit of research in how you recover from noise? Because I saw recently there was a lot of papers on actually getting a video or an image that's completely distorted and it can still actually recreate the original.
Yeah, in our case, it's really hard, and we have a very interesting day today here, discussing how we can even design an attack in order to try to figure out how to extract information. But in the approach we are following, since it's really hard to compare the raw data, any number generated with the raw data, with the final result, because even the format is different. The raw data is this call detail records, that is this information about the phone calls, and the final results are just trajectories along roads. So we are still trying to figure out how to define a value, something quantitative that is measuring the same thing in one version of the data and in the other to compare the thing. And we figure out that we can put in the database, in the original raw data, some fake data that represent a person moving in some particular location. Like in the sense that you know exactly the trajectory of that person. And trying to find that person in the final result. Really to localize and figure out which is going to be his next movement. And I'm pretty sure that is out of the game in the sense that it's going to be impossible. First, because we also filter if the activity is less than 100% contributing to that particular thing, we don't even compute. I mean, we don't even analyze that because we are checking here the big numbers, right? So probably in some middle steps of the process would be interesting to check that. But the final result that we deliver to clients, to local governments and things like that, and politicians in particular, it's really, really impossible to identify someone, I would say. But yeah, it's really interesting because I want to find a quantitative way to explain that is secure enough.
Yeah, super interesting. Really good illustration how to use de-individualized data, for example, safe planning and so on. But just to clarify for me, I thought about the study as you said that hyper-personalized targeting in political ads or marketing ads. Is it that you think it doesn't work, or is it
Yeah.
or that your way